So the first thing you want to do is you want to update your repository. So just git pull and grab the latest files. So there should be quite a lot of stuff for you. So, yeah. Okay, so tonight we'll be doing a decompilation, basically decompilation. We're going to play around with Java bytecodes and Python bytecodes. And it's going to be really easy because you're going to get you're going to be able to get source code back. So the first thing you need to do is let's see, you need to get Java installed. So just run this. Yeah, I installed it already. So just get it installed, and maybe I just like talk a bit while it's installing. So basically, today we're gonna do Java, right? So we have a little Java app here, and you know when you do Java, you get a class file when you compile it, and if you try to read it directly, you get like, a whole bunch of nonsense, right? So all of this, while you still do have some information like strings, a lot of strings, and some class information, you don't really have much. You can't really read what's going on just from looking at this cat, right? Okay, so what? Anyone has any idea how we're going to figure out what this program does apart from just running it? So if I run it, um, like that, Java Snow. Actually, I haven't heard of that. What's that? What's it about? You should look at that. You should show us on like on your screen. Do you have a screen? Okay, maybe later. Should take a look at that. So, but right now, I'm just gonna do it like the old boring way. So we're gonna do the old boring way with decompilation and yeah, and that sites. But okay, let's take a step back, right? And just okay, like can we do it without decompiling it? Like right now, everyone knows how can you do it without decompiling the whole app. Yeah. What's Java Snoo? Let me Google it. Okay, we should try and look at this. You can try JDB, but there's actually something else like this, something called Java P. Yeah, Java P. So what Java P does is it lets you look at a lot of information about the file. So like right now I can see these are the headers, but if you use -c, you actually can get the bytecode, the opcodes like directly. So it's not a lot of information, but you can see like for example, if I look at here, there are a little bit of information, little bits of information. And if we turn on the other flags like constants, sorry, yeah, constants, what? Yeah. So you can get information like this. For example, you can see now that There are a lot of strings and stuff here. So this is how you can get it without using Java Snoop or anything else, or JDB, or actually not JDB, but without Java Snoop or using a JD decompiler. You can kind of read bytecodes just from here, and this comes with the JDK, so it's all native. But of course, we want to do decompilation today, so I'm too lazy to get the environment running on Vagrant. So what I did was we're just gonna go decompilers Java online and use this one. Which one did I use? Nope, this one. Yep. So everyone's installed Java already. Sorry, everyone's installed Java already, right? Um, let's just look at what this class does. So okay, just by playing around and looking at this, you can see it's taking 3 integers using scanner. So if you type 3 integers in, you get some result. So it looks like there are 3 steps. You have to pass the first test, the second test, and third test, and then you get a UN message. If the test fails, you get this message basically. So that's basically a high level overview. If you look at this is not so easy to reverse using this method. So let's decompile and see what we get. Yeah, so you can get some pretty nice information back. Okay, so let's go through the logic and figure out how can we win this program. So okay, it does it in steps. So we have to pass this hot dog method first, right? So what hot dog does is it basically checks if n, the input hot dog, is divisible by 42. So okay, let's pass this. So someone just give me a number that's divisible by 42. Okay, you guys have no imagination. Okay, I'm just gonna show this one. So we've passed the first test. That's pretty easy. So let's look at the next one. So we need to pass party pet now. In party pet, so anyone recognize what this function is? There's actually a name for this kind of functions. Not serial. I mentioned it in one of the previous function. What? Okay, I'll show you again. This one. Okay, it's a multiplicative hash function. Yeah, it's a multiplicative hash function. So basically, what makes it so, right, is because this number is always being operated on by kind of a set constant that changes and is added to the input. So this is a bit hard to come up with a number like on the fly for this. So what we have to do here, right, is we have to go through this loop 3 times, and then at the end of the loop, you have to get this number. Okay, so anyone have any idea how can we get a number at the end of this whole operation? It's not very trivial. We have to do a bit of work to do this. So there are 2 ways basically. Um, I think some of you can come up with a naive way, right? 1020. Does 1020 work? Nope. I don't know. CS 1020 doesn't work. Come on, try give me a number to get to give me a number that when you pass in, it comes up to this number. Yeah, I'll paste the whole function there. So what we have to do is we have to get this number at the end of this operation. So there are two ways, but can anyone, figure out those two ways? Euclidean, okay. Let's try. Yep. So Trina, you probably did it by brute forcing, right? Mentally, you minus it or something, right? Okay. Yeah, that's the one of the ways you come up like an equation that like in terms of n or x. So you would solve for n or x. That's one of the ways. The other naive way is you just write a Python script, like a really simple Python script that does okay, example to solve for. Oops. Yeah, so you just do something stupid like this, and you should be able to get your answer pretty quickly. Um, yep, just get the same answer from this brute force method. So yeah, so that's our second number. Our first number is 42. The next number is this. And now we've got to get past the third number, so yeah. So the third number is given by this equation. Um, you're supposed to pass in a number that when you apply this equation, it must be equal to this equation. So okay, so anyone has any solution? I'll paste it in the chat. So notice that it's 2 power n plus n plus 491, right? So how do we find a number that gives us um this big number out of this equation? Is there anything you can use? Is there anything you can program? Okay, so someone give me this the query string for that. Showing you're boring. Okay, so yeah, if you use Wolfram Alpha, right, and we use that quite a lot in CTFs, you actually can you really get a lot like this kind of equations out of reversing problems. So you would just find out what is the general solution. Like for example, the multiplicative hash function level, you actually could come up with a general solution, a general equation, and then you find what they want to compare against, and then you put it in Wolfram Alpha, and sometimes it gives you a really nice answer. Like, okay, you get two answers like this because it's a quadratic equation. Um, but you can see that definitely there's no way you can enter in a negative number. Actually, you can, but it doesn't really make any sense. So you have to take this other number instead, 2645.21696.2 and 2645, and see, okay, we passed the crack me. So yeah, these are a lot of the simpler crack me's you see in CTFs, where you just reverse some simple mathematical equation and solve those constraints, and you get your resulting blank. Okay, so that's the Java stuff. We really should look at the Java Snoop. Maybe like Ryan can show us next time or something. Okay, so the next thing is it's a Python script, and okay, Python scripts are not usually compiled. Oh, cool. So Python scripts are not usually compiled. But you can actually force them to compile by importing it as a package, or you can use something called compile or something. Yeah. So this actually will compile your Python scripts, and it will result in something like this. Where it's similar to the Java thing. It's all in bytecode now, and all you get is just a little bit of string information, a little bit of class information. Yeah. So from here, anyone has any idea how we can proceed? Okay, like just let's say we want to get something, we want to make this bytecode readable right now, but we don't want to decompile it yet. No, there's no such thing as Python fee. Okay, if we dig and we look for Python disassemblers, right? We actually can find that Python has a disassembler built in. So if we try to disassemble a file, let's see. Yeah, I think we can do this. Python import this, import Morty, this dot yeah, we actually can get the Python opcodes from this, and you can see straight away that there are two functions in this um, program. There is main, and then there is validate. And again, you can see this rough structure. You can see it's actually looking at for a file called license.key. If it is, it jumps to here probably. If it's not, it exits after printing this bit. Yeah. So after, if it exists, it opens the file and reads the file, and it calls validate on the contents. So if validate passes, yep, if validate passes, you print out this bit. It says it's registered. Otherwise, it says your guts are eaten. So okay, looking at validate again, right? This is not so simple to look at again. So we've got to try and make this as close to source code as possible. So anyone got any suggestions again? I don't think that's Python Snoop, right? I don't think it's a Python Snoop. Yep. So anyone got any suggestions? Like how do we turn this stuff into a nice Python source code file? Any thoughts? Okay, okay, uncompile is the thing we're gonna look at, and it's really good. So to install, okay, I assume you guys are following with the Vagrant, but if not, you can just install however like on your machines. You gotta install Python pip first, and then after that you gotta install uncompile 2. And once that's done, um, all that's left to do is just you can call uncompile 2 from command line on the Python class file, and you get your source code back. So it's actually pretty accurate because Python doesn't really get rid of all the symbol names and stuff. Okay, so now we've got the source code, right? Now someone suggest something that we should do first, and to at least get the program to run properly. I'll just paste the source code. So how do we get the program to at least get past the license key bit? Okay, so you're going to create a license key file. So what should be in our license key file? Okay, let's try true. Like that? Like just true like that? Okay, okay, let's just try running it. Okay, no, it says product not registered. Anyone can spot why? It's a very funny problem. Yeah, that's a typo. So license key. So now we're gonna try putting true now, because apparently Python doesn't take the lowercase true as true. So let's run this thing again. And it says your guts get eaten right now. So we failed to validate. We failed to validate. But why? We probably need to modify this a bit. So let's just take it step by step and look at what the license key looks like. Um, okay, so we have a key, right? And this key is being split by new lines. So it probably spans multiple lines, right? And okay, so we've got the name on the first line, and it checks if the name upper is not equals to the name supplied. So if it's not equal to the name supplied, it immediately returns false, which means this bit would fail, and you guys get eaten. So what we need to do is we need to make sure our name that we supply is uppercase. So I'm just gonna put in potato. Okay. So the next step is that we need to figure out what this bit does. So pretty cool is in Python you have something called map, which basically maps this function onto all the elements of this expression. And what this expression does is it will split a string according to this delimiter, which is a dash. So let me just show you. So for example, if my string contains like 1, 2, 3 dash 4, 5, 6, 7 dash 8, 9, 10, 8, 9, 0, and I split according to dashes, I get this thing. But notice that these numbers are all strings. So if we use a map on this with an integer as a function, we can convert all this into numbers in the list just by this nice simple line. So in this case here, this contains an array of numbers split according to the dash. So the next line says that these numbers have to meet certain constraints, like the zeroth and the first number have to be equals to okay, the addition of the zeroth and the first number have to be equal to the second number, and the third and the fourth number multiplied by 4 modulus 12 has to be equal to the fifth number. So someone just give me a string that meets this constraints really quick. Okay, let's try this. Okay, and for the last string, it's really simple. Just someone just throw it to me. Okay. Okay, Cheng says potato, so I'm gonna put potato. Let's try. No, it's wrong. You're an idiot, Chen Yang. Yes, let's try Iron's bit. And Iron's one worked. So yay. So that's pretty much it for today. It's supposed to be really short because we all want to go sleep. So that's our great leader, North Korea. Yeah, let's look at the demo. I click this. Yeah, no problem. Let me see how I can make you present. Yeah, okay, Ryan, if you show your mic, um, your screen. No, you guys see anything? No, we don't see anything yet. wait, there are two Ryans. Okay. Yeah, we can see you now. Let me present your screen to everyone. You guys able to see your screen now? Yeah. Okay, cool. Let's look at Java Snoop. Wow. Well, that looks really cool. Does it work for Android stuff? Yeah, you can't put potato in because it takes integers. Wow, that's mega cheap. That's like the equivalent of doing set EAX to 0 or something. Okay. Cool. Okay. Okay. You earn like 4 billion met credits. Oh, it'd be cool if it worked on Android. JavaScript. We should look at that. Hmm? Whose question? Oh wait. Okay. Okay, I should answer a question like, let me show my screen again. Okay, so I'm just gonna do a quick program really fast. So let's say quick, let's see. So let's say this program just returns 1 and it's impossible for blah to be equal to 0, right? Okay, so this thing should not run currently. Ah, no, it's not that. It's because I need to declare this before main so that it will. Yeah. No, I don't have any. Yeah. No, it's not. It's not that, right? Did I forget it? Yeah, I forgot it. Okay. So if you run this, you will definitely um not run properly. So you get boo, right? Because it's impossible for it to be 0. So let's just use GDB and try and get our raw. I'm breaking on main. So I'm going to scroll and let it run. This says, okay, I'm just going to go all the way here. Let's try into the call. So easy. So I'm going to go to the call and look at what happens. It moves 1 into EX. So once I get out of this place, EX is going to be 1 and it's going to test whether EX is 0. So what I can do, like what Ryan did for Java Snoop, I can just set EX to 0, like he set the return value to true, and now I'm going to be able to pass that test, and it's going to print raw, and so that's what I meant by just setting EX to 0 in GDB. Yep. Yeah. So anyone else want to know about anything? Okay, let's turn this off now.